Welcome to Merging Data Frames with Pandas. My name is David Arolaya. I'm an applied mathematician and data scientist. This course is all about merging and combining data frames for your data science needs. Your data really exists as data frames from the outset. You generally have to deal with text files, spreadsheets, and databases. Let's first check out how to read multiple files into a collection of data frames. The primary tool we've used for data import is readcsv. This function accepts the file path of a comma-separated values file as input and returns a pandas data frame directly. readcsv has about 50 optional calling parameters permitting very fine-tuned data import. Pandas has other convenient tools with similar default calling syntax that import various data formats like Excel, HTML, or JSON into data frames. To read multiple files using pandas, we generally need separate data frames. For example, here we call pd.readcsv twice to read two CSV files, sales January 2015.csv and sales February 2015.csv, into two distinct data frames. It's generally more efficient to iterate over a collection of file names. With that goal, we can create a list file names with the two file paths from before. We then initialize an empty list called data frames and iterate through the list file names. Within each iteration, we invoke readcsv to read a data frame from a file, and we append the resulting data frame to the list data frames. We can also do the preceding computation with a list comprehension. Comprehensions are a convenient Python construction for exactly this kind of loop where an empty list is appended to within each iteration. You can check out DataCamp's Python programming courses for more details on comprehensions. When many file names have a similar pattern, the glob module from the Python standard library is very useful. Here, we start by importing the function glob from the built-in glob module. We use the pattern sales *.csv to match any strings that start with the prefix sales and end with the suffix .csv. The asterisk is a wildcard that matches 0 or more standard characters. The function glob uses the wildcard pattern to create an iterable object file names containing all matching file names in the current directory. Finally, the iterable file names is consumed in a list comprehension that makes a list called data frames containing the relevant data structures. Now it's your turn to practice reading multiple files into data frames in the exercises. Now that we can import many files into individual data frames, let's investigate sharing information between data frames using their indexes. This is essential for combining data frames later, as indexes are the means by which data frame rows are labeled. Let's make a brief note on terminology. The plural of index in English can be indexes or indices. Both are acceptable usage. Let's adopt the convention of using indices as the plural of index when referring to individual labels within an index data structure. By contrast, we can use indexes as the plural of index with reference to many index data structures associated with several pandas series or data frames. This is not a standard convention, but it helps us resolve ambiguity in thinking about, say, sets of indices within many indexes. To start, let's load two data frames of temperature data recorded from Pittsburgh in 2013. For both calls to readcsv, we use the index call argument to specify which column becomes the data frame index, month in both cases. Remember, the index is a privileged column in pandas, providing convenient access to series or data frame rows. We can examine our data frames wmean and wmax more closely. The mean temperature F and max temperature F columns are, respectively, the average and maximum daily temperatures in Fahrenheit observed during 3-month intervals or quarters. For both data frames, the column month is the data frame index. The month listed in each index row is the first month of each quarter. By virtue of how the CSV files are sorted, the index of wmean is in alphabetical order, while the index of wmax is in chronological order. The former gives a distorted sense of time-dependent trends. The data frame indexes are accessed directly with the .index attribute. Both wmean and wmax have indexes of type object because the index labels are strings. The type function shows us the data type of the indexes. We can define a list called ordered to impose a deliberate ordering on the index labels of wmean. The dataframe reindex method creates a new dataframe wmean2 with the same data as wmean, but with a new row ordering according to the input list ordered. We can see that wmean2 has the desired chronological ordering. The original alphabetically ordered dataframe can be recovered with the dataframe sortIndex method. Pandas index labels are typically sortable data, such as numbers, strings, or datetimes. The input argument to the reindex method can also be another dataframe index. For instance, here we use the index from wmax to reindex wmean in chronological order. When a suitably indexed dataframe is available, the reindex method spares us having to create a list manually or having to sort the index. The specific index labels provided to the reindex method are important. For instance, if we invoke reindex again using an input list containing a label that is not in the original dataframe index, December in this case, an entirely new row is inserted and filled with the null value NaN or not a number. We can also use reindex to see where dataframe rows overlaps. For instance, here we reindex wmax with the index of wmean3, showing that wmax does not have a row labeled December either. Using the method dropNA removes entire rows in which null values occur. This is a common first step when merging data frames. Finally, we should realize that order counts. That is, wmax.reindex of wmean.index is not the same as wmean.reindex of wmax.index. The latter fixes the row order as desired in wmean. The former replicates the misleading alphabetical row order in wmax. This is likely not desired. Try reindexing data frames now in some of the exercises. Let's explore various arithmetic and mathematical operations between Pandas series and data frames. We load daily weather measurements for Pittsburgh from 2013. We make date the index, and we use parseDates equals true to get datetime objects. With datetime indexes, we can use convenient strings to slice, say, the first week of July from the precipitation in column. The precipitation data are in inches. Let's convert them to centimeters. We use the asterisk to multiply a series element-wise by 2.54. Remember, we can broadcast standard scalar mathematical operations. Here, broadcasting means the multiplication is applied to all elements in the data frame. Let's find the percentage variation in temperature in the first week of July. That is, the daily minimum and the daily maximum temperatures expressed as a percentage of the daily mean temperature. We can compute this by dividing both the min temperature F and the max temperature F columns by the mean temperature F column and multiplying both by 100. To begin, slice the min temperature F and the max temperature F columns as a data frame week 1 range. Next, slice the mean temperature F column as a series week 1 mean. Dividing the data frame week 1 range by the series week 1 mean doesn't quite work. The column labels don't match, so the result has all null values. Instead, we want to use the data frame divide method with the option axis equals rows. The divide method provides more fine-grained control than the slash operator for division itself. This broadcasts the series week 1 mean across each row to produce the desired ratios. We can see the temperature range varies by at most about 10% from the mean in that week. A related computation is to compute a percentage change along a time series. We do this by subtracting the previous day's value from the current day's value and dividing by the previous day's value. The percent change method does precisely this computation for us. Here, we also multiply the resulting series by 100 to yield a percentage value. Notice the value in the first row is nan because there is no previous entry. Finally, Let's examine how arithmetic operations work between distinct series or data frames with non-aligned indexes, which happens often in practice. We'll use Olympic medal data from 1896 to 2008. Here are the top 5 bronze medal winning countries, the top 5 silver medal winning countries, and the top 5 gold medal winning countries for that period. All 3 data frames have the same indices for the first 3 rows: United States, Soviet Union, and United Kingdom. By contrast, the next 2 rows are either France, Germany, or Italy. Let's compute the total medals awarded to each country. We start by adding bronze and silver. Here, we add 2 series of 5 rows and get back a series with 6 rows. The index of the sum is the union of the row indices from the original 2 series. Arithmetic operations between pandas series are carried out for rows with common index values. Since Germany does not appear in silver and Italy does not appear in bronze, those rows have nan in the sum. On examination, we see the value 2,247 for the United States row is the sum of 1,052 and 1,195 from the corresponding rows of the bronze and silver series respectively. We can get the same sum bronze plus silver with a method invocation using bronze.addSilver. The null values occur in the same places. The default fill value is nan when sum and rows fail to align. We can modify this behavior using the fill value option of the add method. By specifying fill value equals 0, the values of Germany and Italy are no longer null. Just as the divide method is more flexible than the slash operator for division, the add method is more flexible than the plus operator for addition. Adding all 3 series together yields 6 rows of output, but only 3 have non-null values. That is, France, Germany, and Italy are not index labels in all 3 series, so each of those rows is nan in the sum. We can also chain multiple method calls to the .add method with fill value equals 0 to get rid of those null values in the triple sum. Now, you can get some experience with standard arithmetic operations and methods for series and data frames in the exercises.